Alright, hello everybody. Again, Mr. Noyes here. We're here to talk with you guys about direct variation and inverse variation. As you know, we've been working through linear functions. We've been working through graphing the form y equals mx plus b. Today we're going to be seeing two special relations between x and y. One would be, again, direct variation, and the other one being inverse variation. To give you a little bit of information here, we have the, of course, slope-intercept, y equals mx plus b. With this linear function, we have a special case, which is going to be a way to, kind of reorder this in such a way that direct variation may come from it. And we'll be able to see this is going to be the case when b is equal to 0. So you do not have what b was. Again, b was the y-intercept. So again, remember that we do not have a y-intercept in this problem. In fact, it's just going to be b. So, it's going to be b equals to 0. So we just have the form y equals mx. From this form here, y equals mx, the m represents our slope, but we're going to have a variable brought in place, which you'll see in your textbook. It's going to be k. So k, we're going to have that be in the form for m, so it'll be y equals kx. This right here will be one of the forms that you'll see for direct variation, y equals kx. There's another way of rewriting it though. The other way to rewrite it would be to solve for k. So, or k equals y over x. This one or this one, both ways to find the direct variation based on the problem that you're given. We'll see some examples today. The next one would be inverse variation. Inverse variation, as you hear the word inverse, we're going to be varying inversely your y's and x's with one another. So in here, you're direct, y equals k times x. For this one, for inverse variation, coming from this guy, it would be y, whoops, sorry, that's a messy y. It would be y equals k, and then it's going to be over x. And then we also have another way of rewriting this, just like how we had up here. We have two different ways. The second way to rewrite this would be solving for k. K equals, cross multiply here, k equals y times x. So one way, two ways of going through and solving for what we would have for inverse variation. So we would have inverse variation, y equals k over x, or k equals y times x. So we have the constant of variation, which is going to be k. So k stands for the constant of variation. Just so you're understanding what this is, it's going to be the value that you'll see in your textbooks. It's going to be something that we're varying by, and it's going to be the constant k. All right, next slide. Identifying examples of direct or inverse variation. So we have three examples here, all table form, x's, y's, and again, our formula is written down for us, inverse and direct. xy equals k, or y equals k over x for inverse, and direct is y equals k times x, or y over x equals k. Again, I have them on this slide, so it may be easier in case you didn't get them copied down if I went too quickly from the first slide. And again, remember, k is going to be your constant of variation. Okay, so you want to see which one this is, if this is going to be direct or inverse. So we're going to look at it, and we're going to see we have our x's and our y's in here. So of course, this is what we're going to look at, x times y. We'll look at this, y over x. Whatever one gives us the constant variation, that means that's what's going to be. So 7 divided by, so we're going to have it as y over x. So 30 divided by 7, 15 over 14, or 10 over 21. Do any of those equal to each other? In fact, they all have to be the exact same thing, and that is not true. So we know this is not going to be direct. But if I look at inverse, it's x times y equals k. I have x is 7, y is 30, that's 210. 14 and 15 is 210. 21 and 10 is 210. So this right here has inverse So this is inverse variation. With the variation constant k, k equals 210. Okay? Next example. Same thing, same order. I'm going to check to see if y over x is the same thing as for 7 over negative 5. Gives me a fraction. Can't reduce that. 12 over negative 4. Negative 3. Right there I'm going to stop because I know that negative 3 is not equal to 7 over negative 5. So I'm done with that. Check for inverse. Inverse, remember, you're multiplying x times y. X times y for inverse. Negative 35 you get there. Negative 48, again, I'm going to stop because I know it doesn't work. If the first two aren't going to match, then you know the third one's not going to come around to match either. So right now I can see that this is neither inverse nor direct. So in case, if you're wondering what you write down, you will write down the word neither. Alright, so neither. This neither has direct or inverse variation. The next one. For the next one, it's going to be 4 times negative 8, which is negative 32. I went in a different order this time. I'm checking to see if it's inverse first. X times y. 4 times negative 8, negative 32. 10 times negative 20, negative 200. That doesn't work. But let's take a look to see if direct works this time. So y over x. So y. Negative 8 over 4, negative 2. Negative 20 over 10, negative 2. Right there I know, and I'll follow through for the third one. Negative 24 over 12, negative 2. That works. So I know this has direct variation with my variation constant of k equal to negative 2. So k equals negative 2, and this is direct. So that's direct variation. Alright, go to the next slide. So going to the next slide here, we have this question. The variable x varies directly with y. When y is 7, x is 5. Find y when x is 15. So for this setup right here, we have, again, the formula is written down for us. So we want to find out what y is when x is 15. Our question is given to us that x varies directly with y. So we see that we'll find out that when y is 7, x is 5. Alright, so remember, we could write each one of these in two different ways here. I'll go back to the next slide, again, that has those written down in two different ways. If you want to copy these down, if you don't already have them down, we're going to go to the next slide again. Alright, so the variable x varies directly with y. When y is 7, x is 5. So we're going to go ahead here, and we'll see that my y is equal to 7, and my x is equal to 5. So we're seeing that this direct is going to be y equals k over x, so I'll have k times x. So y is 7 equals k, which is going to be 5 right here. So k is equal to 7 over 5. K is 7 over 5. So I want to find y when x is 15. So what I'm going to do now is I'm going to go ahead and I'm going to take now this k that I found, and I'm going to plug it back in here for k when x is 15. So the second part of the problem will be as follows. Y equals 7 over 5 times 15 over 1. And you'll see here, 5 goes into 15 3 times 21. Alright, ignore the bell. So we'll go ahead here, then we have that y is now going to be 21. So that's your answer for this problem here. You'll see that y is equal to 21. Next example, the variable x varies inversely with y when x is negative 12. Y is 4. Find x when y is negative 6. So I have my situation here. When x is negative 12, y is equal to 4. I'll see, again, this is inversely. So I'll use this. So I'll say negative 12 times 4 equals k. K is equal to negative 48. So I have negative 48 for k. Now I want to find x when y is negative 6. So again, I have my k value. I want to go ahead now and find x. So I'll say negative Solve for x. Divide by -6. Divide by -6. Reduce out. -48 over -6 gives us what number? Almost. What is it? Alright, there we go. So we know then that x is going to be giving us 8. And so for this answer here, we have it as x equals 8. Hope you guys enjoy this. Thank you.